All right, let's take a look at today's lesson. This is a continuation from Friday's lesson on fundamental theorem of calculus. And so we have some additional problems to work through just to make sure we have a pretty good handle on the concept. So let's take a look at the first problem. The first one is an abstract problem like the ones we were doing on Friday. And so we're given a position value, f of 3 equals 5. We're told that the first derivative is continuous, and then we are given an integral value of the integral of the first derivative is 20, and we're asked to find f of 8. So just like we worked on Friday, we want to set up our integral. Using the fundamental theorem. And so we know that that's true because of the fundamental theorem. We are told the value of the integral is 20. We don't know f of 8, but we do know f of 3. We were given that. So now it's just a matter of moving the 5 over. So this is basically very similar to some of the problems that we did on Friday, just showing you how helpful the fundamental theorem is on really abstract problems. These are types of problems you will see on the calculus exam in this kind of form. It's real abstract. You've got to understand how to do the fundamental theorem to be able to work through. Okay? The second problem is just a bit of a variation on what we have been working on. We are given basically pieces. We're told that from negative 1 to 4, 3f of x plus 2 dx is 28. And we're asked to find just the integral from negative 1 to 4 of f of x dx. So it's written in a little bit of a different way, but we're going to tackle it like we would the others. The only change would be here is that I'm going to use some of my rules for integration to break this apart so that I can kind of isolate this piece of it. So let's use our integral rules. We know that we can split it apart by addition. We also know that that 3 can be pulled outside. The constant can be pulled outside. And please note that the 3 does not affect the 2. It's only affecting the f of x. So my first step is going to be to pull it all apart. And so I have 3 integral negative 1 to 4 of f of x dx plus integral from negative 1 to 4 of 2 dx, and that's supposed to equal 28. Okay? Yes? Is that okay? Okay. So we're pulling it all apart. This one, you have a couple of different ways to choose for solving. You can, find its antiderivative, do f of b minus f of a, or you can kind of do this one in your head. We worked with these when we were working on geometric formulas. Remember that? When y is 2. And so that I would like for you to think about that. Not that you have to do it this way, but I would like for you to think about it. If I have from negative 1 to 4 at y is 2, I would have basically this line. It creates a rectangle. Right? It's a rectangle whose height is 2 and whose width is 5. So this integral is will be 10. Whether you do it this way or whether you find the antiderivative and do f of b minus f of a, you're still going to get 10. So it's really up to you how you would like to do it. If you can do this part in your head, it just might make you go a little bit faster, but again, it's whatever you feel more comfortable with. So we have the integral from 3 times negative 1 to 4 of f of x dx plus 10 equals 28. So now we do what we have been doing in algebra for many years, which is solve for this unknown. I'm going to move the 10 over and divide by 3. I subtract a 10 and get 18, divide by 3 and get 6. So the integral from negative 1 to 4 of f of x dx is 6. Okay, is that okay? Our very last one isn't an abstract problem. It just is a problem that we need to be sure we know how to do. We've worked with splitting the integral apart with absolute value equations. And we talked about that before. If the absolute value is linear, the geometric technique would be quicker, just finding the area of the triangles. If it's not linear, we have to pull it apart and do 2 or more integrals. Here, we have to pull it apart and do 2 integrals because this spans both pieces. This starts at -1 and goes to 4. This piece is valid when x is less than or equal to 2, and this piece is valid when x is larger than 2. So we're going to have to split it because of the way this is set up, because it's a piecewise. So let's do that. Let's set this up. We want to go from -1 to 2, and we want the piece where x is less than 2, so 3x minus 1 plus the integral from 2 to 4 of the other piece, x squared plus 1 dx. And so probably, I don't know, maybe splitting it apart might be a little challenging. Usually arithmetic for me is challenging. So once we get it split apart, we find our antiderivative. We do f of b minus f of a. So let's do that. So the antiderivative of this would be, what, 3/2 x squared minus x, evaluated from -1 to 2. Whoops. And the integral, the antiderivative over here would be, what, 1/3 x cubed plus x from 2 to 4. Okay? And so we want to go ahead and do our f of b minus f of a. So 3/2 times 2 squared minus 2 minus, let's substitute the -1 in. Let's see, -1 squared is 1, so it's 3/2 plus 1. Okay, we okay on the first piece? Alright, so then the second piece, I'm going to put a 4 in, so 1/3 4 cubed plus 4 minus, and now we want to sub the 2 in, 1/3 2 cubed plus 2. Now, all of that arithmetic, I'm not going to work through the arithmetic now on here just for time's sake. When you work through the arithmetic, you should get 133/6. Yes, cut right to the chase. Okay? Yeah, right, you can see that. Sure does. You just, okay. All right. So how are we? We okay with that? We good? All right.